Hello guys, my name is Bino, and in this video we'll be going through question 2 from the April 7 2021 N5 mathematics question paper. And question 2.2 states that we must calculate dy over dx of the following by using the derivative of sin x and cos x as well as the rules of differentiation. Before we can differentiate, we know from our logarithmic laws that if you have e to the power ln of a, this is equals to a. If you have ln to the power e to the power ln of x squared, this is equals to x squared. So in our case, e to the power ln of tan of x is equals to tan x. So y will be equals to tan x, and as you know, tan x is equals to sin x over cos x. So instead of differentiating the tan x, we will differentiate the sin x over cos x. So we have y is equals to sin x over cos x. Since we are dividing the sin x with the cos x, we have to use the quotient rule. So the quotient rule, if you had y is equals to f of x over g of x, the derivative of y with respect to x will be equals to the derivative of f of x multiplied by the g of x minus the derivative of the g of x multiplied by the f of x, all divided by g of x squared. So we use this quotient rule with this quotient. So dy over dx will be equals to the derivative of sine is cos x multiplied by the cos x minus the derivative of the cos x, which is negative sin x, multiplied by the sin x, all divided by the cos x squared. Cos x multiplied by cos x is equals to cos squared x. This negative multiplied by that negative will be positive, and the sin x multiplied by sin x is equals to sin squared x over cos of x squared, which is equals to cos squared x. We know from our trigonometric identities that sin squared x plus cos squared x is equals to 1. So in the place of this cos squared x plus sin squared x, we substitute 1 over cos squared x, and also from our trigonometric identities we know that 1 over cos x is equals to sec x. So our dy over dx, which is equals to 1 over cos squared x, we can write it as 1 over cos x multiplied by 1 over cos x. So in the place of this 1 over cos x, we substitute sec x, and in the place of that other 1 over cos x, we also substitute sec x. So dy over dx is equals to sec x multiplied by sec x, which is sec squared x. So our dy over dx is equals to sec squared x. Question 2.3, we have to determine dy over dx in each of the following cases. So dy over dx of this whole thing, so we start with the parenthesis 10 multiplied by ln of x squared plus 1 minus arctan of 6x. 10 minus 1 is equals to 9. So now we differentiate the inner function. So the derivative of ln of x squared plus 1 is equals to 1 over x squared plus 1, but we also have to differentiate the inner function x squared plus 1. So the derivative of x squared is equals to 2x. The derivative of 1 is equals to 0 minus the derivative of arctan of 6x. So the derivative of the arctan We can find it also on our formula sheet. It's 1 over 1 plus the 6x squared multiplied by the derivative of the 6x according to the chain rule. We also have to differentiate the inner functions. We differentiated the inner function of the ln, so even in this case we have to differentiate the inner function of the arctan. So the derivative of 6x is equals to 6. So we can clean this. So the rule was that there is no need for us to simplify. So we have 10 ln of x squared plus 1 minus arctan of 6x raised to the power 9. 1 multiplied by that 2x will be equals to 2x over x squared plus 1 minus 1 multiplied by the 6, which is 6 over 1 plus 6 squared is equals to 36, and x squared is equals to x squared. So this will be our answer for question 2.3.1. For question 3.2, we have to use the quotient rule. So if you have y is equals to f of x over g of x, the derivative of y with respect to x is equals to the derivative of f of x multiplied by the g of x minus the derivative of the g of x multiplied by f of x, all divided by g of x squared. So we differentiate y is equals to 1 plus arcsine of x over 1 minus cos of arcsine cos of x using the quotient rule. So dy over dx, we differentiate the 1 plus arcsine of x. The derivative of 1 is equals to 0. The derivative of arcsine of x is equals to 1 over the square root of 1 minus x squared multiplied by the denominator 1 minus cos of x minus the derivative of the denominator. The derivative of 1 is equals to 0, and the derivative of the negative cos of x will be equals to negative 1 over 1 minus x squared. So the derivative of the arcsine and the arccos are available on the formula sheet, multiplied by our numerator 1 plus arcsine of x, or divided by 1 minus cos of x squared. So the rule was that we must not simplify it. It's not necessary for us to simplify. So we have 1 over the square root of 1 minus x squared multiplied by 1 minus cos of x minus, so this negative multiplied by that negative will be positive, 1 over the square root of 1 minus x squared multiplied by 1 plus arcsine of x, all divided by 1 minus cos of x all squared. Question 2.4, we have to calculate with the aid of logarithmic differentiation dy over dx if y is equals to 2x minus a to the power 8x all raised to the power sine 2x. Question 2.4, we have to calculate with the aid of logarithmic differentiation dy over dx if y is equals to 2x minus 8. Question 2.4, we have to calculate with the aid of logarithmic differentiation dy over dx if y is equals to 2x minus e to the power 8x all raised to the power sine 2x. We know with our logarithmic differentiation, with our logarithmic laws, if you have ln of a to the power 2 this will be 2 ln a, or ln of b raised to the power x. This will be equals to x ln b. So in our case, we introduce ln both sides. So this one, according to our exponent, our logarithmic laws, will be equals to sine 2x multiplied by ln of 2x minus e to the power 8x. So from here, we have to differentiate. So the derivative of ln of y is equals to 1 over y, but since we are differentiating with respect to x, whenever we differentiate anything which has y, we also have to introduce dy over dx. So to differentiate this side, we have to use the product rule. So with the product rule, if y is equals to f of x multiplied by g of x, the derivative of y with respect to x is equals to the derivative of f of x multiplied by g of x plus the derivative of g of x multiplied by f of x. So we start by differentiating the sine 2x. So the derivative of the sine 2x is cos 2x. The chain rule also says that you must differentiate the inner function, the function of the function. So the derivative of the 2x is equals to 2. We multiply this by ln of 2x minus e to the power 8x. From here, we differentiate the ln of 2x minus e to the power 8x. So the derivative of ln is equals to 1 over 2x minus 8 e to the power 8x. So we also have to differentiate the inner function. So the derivative of the 2x is 2. The derivative of the e to the power 8x is e to the power 8x. And again, according to the chain rule, we also have to differentiate the inner function of the e. So the derivative of the 8x is equals to 8. And we multiply this by the sine 2x. So our y, 1 over y dy over dx is equals to, we write the 2 first, 2 cos 2x multiplied by ln of 2x minus e to the power 8x plus 1 multiplied by that, even there. So 1 multiplied by 2 minus e to the power 8x multiplied by 8 multiplied by the sine 2x. So we'll have 2 minus, we write the 8 multiplied by the e to the power 8x and also our sine 2x. So the denominator 1 multiplied by the denominator 2x minus e to the power 8x is equals to 2x minus e to the power 8x. So from here, we multiply both sides by y. So that y can cancel out with that y. So we're told to find out dy over dx, not 1 over y, dy over dx. So we can put that y here. We are not supposed to have this y, so in the place of this y, so our dy over dx must be only in the form of x. So we are not differentiating implicitly. So we have to, in the place of this y, we have to substitute that, because that is equals to y. So we substitute 2x minus e to the power 8x raised to the power sin 2x. In the place of y, we still have our 2 cos 2x ln of 2x minus e raised to the power 8x plus sin 2x, 2 minus 8 multiplied by e to the power 8x, all divided by 2x minus e to the power 8x. So this is our answer for question 2.4. Question 2.5, we have to determine dy over dx of the implicit function tan of x squared y to the power 4 is equals to 3x plus y squared. So in this case, the derivative of the tan is sec squared. We have our x squared y to the power 4. We also have to differentiate the inner function of the tan x squared multiplied by y to the power 4. The derivative of the 2x, the derivative of the x is 2x, and also so we multiply this by the y to the power 4 and we derive the y to the power 4. But each and every time when we differentiate anything which has y, we also have to introduce dy over dx, and we have to multiply it by the x squared. So in this case, we differentiated the x squared, it was 2x, we multiply it with the y to the power 4. This time around, we differentiated the y to the power 4 and we multiply it with the x squared. So the derivative of the 3x is equals to 3, and the derivative of y squared is 2y, but each and every time when we differentiate anything which has y, we have to write the dy over dx. So we have to make dy over dx the subject of the formula. So let's multiply, let's distribute the x squared y to the power 4 inside the parenthesis. So this multiplied by that will be x squared y to the power 4 multiplied by 2x y to the power 4 plus x squared y to the power 4 multiplied by 4y cubed dy over dx. X squared is equals to 3 plus 2y multiplied by dy over dx. So we group whatever it is that has dy over dx, we take it to the left, and this case, this has dy over dx, so it's going to remain. This doesn't have dy over dx, so it's going to go to the right. So let's first start by taking the 2y dy over dx to the left. It's going to change sign from positive to negative. 2y dy over dx, and this remains because it has dy over dx. So instead of writing the dy over dx here, let's write the x squared, and let's write the dy over dx later. So we have the 3. So this doesn't have dy over dx, so it's going to go to the right. It's going to change sign from positive to negative. X squared y to the power 4 2x y to the power 4. So from here we take dy over dx as our common factor. So when we take dy over dx, we'll remain with the negative 2y, and we also take the dy over dx as a common factor here, and we'll remain with x squared into x squared y to the power 4 multiplied by 4y cubed multiplied by the x squared, 3 minus x squared into x squared y to the power 4 2x y to the power 4. From here we divide both, because we have to make dy over dx the subject of the formula. We divide by the negative 2y plus sec squared of x squared y to the power 4, 4y cube x squared. So what we do on the left, we also do on the right. So we also divide by that on the right hand side. So these two will cancel out each other, and our dy over dx will be equals to 3 minus sec squared x squared y to the power 4 multiplied by 2x y to the power 4 over negative 2y plus sec squared x squared y to the power 4 multiplied by 4y cube x squared. So from here we can decide to take that 2, which is a constant, and put it in front of the sec squared, and also take that 4 and we put it in front of the sec squared. And this will be our answer for question 2.5.